Today, we are going to see some one important topic in electric traction. Okay, so in electric traction, there is a need of knowing the time and speed curve. Okay, because whenever we design any electrical vehicle appropriately, we should know what should be the speed of the particular electric vehicle. So obviously, by knowing that only we can able to design. Say, for example, in any railway system, it can be divided as a three different category. That is one as a main line, and another one is as a suburban, and another one is a city line. Say, for example, in the city line and all, I think you may know what are all the infrastructure needed. Suppose if we go for electric traction, single catenary wire is enough, and whereas some double catenary or some complex catenary arrangement is needed for main line, because the catenary level or catenary is deciding how much speed of the particular train is going to happen. Say, for example, in a city line and all, within 1 kilometer or 1.5 kilometer, there may be a frequent stop. So accordingly, so if you draw the speed and speed and time graph for the particular one, it will give a different trapezoidal curve. But whereas a main lane and a suburban is giving a different trapezoidal line. So actually, it will not be exact trapezoidal. So if you are just mapping the particular curve in a fixed shape manner, means we can able to get a trapezoidal. So we have to solve that. We should know at initially what time, how long it will take for acceleration, and likewise coasting. So how long we have to cut down the supply by which it will get slowed down. Then how long we have to apply a braking and all. So this can be learned by knowing the speed time curve of a particular train. Okay, so automatically particular thing only we can able to design the particular electrical vehicle requirement. Suppose this much speed if it is required, so how much the power requirement, energy requirement, and accordingly we can go for sizing of, and accordingly we can design the power modulator and etc. So this is the very important concept. Based on this only we are going for the sizing of motor, and also if the sizing of motor means automatically power modulator, and also what is the capacity of the battery. Suppose in case of electric traction, what is the capacity of the energy requirement has to be feed through the transmission line, overhead transmission line. So these are all the things is further decided by knowing the speed time curve. So very important concept, the speed time curve. So this is what exactly in any engine, in any engine. So especially a locomotive, electric locomotive. Okay, this is what we hear inside that. It is a schematic diagram of electric locomotive. As we have mentioned, this is the overhead conductor. So automatically, when the vehicle is moving in this direction, automatically what will happen is through pantograph that will collect. So in order to give certain pressure and having a continuous contact with that, it is arranged in this size. Then it circuit breaker. So automatically if any excess current and all is going, so this circuit breaker will prevent, automatically it will prevent. So but very rarely only happening. So automatically when it is happening, when it is happening, with this ma. automatically the circuit breaker usually of a very high current rating circuit breaker, usually air and vacuum circuit breaker type of circuit breaker is used here, because most of the instant it will be safe only. But sometimes if there is any possibility, so if instead of drawing a over current, if it is any short circuited or transformer problem and all, so it is preventing, it is like a protecting devices in any electric vehicle arrangement. Then after that insulator, so automatically the live wire should touch with the metal body or outer body of the any engine. Okay, so automatically this insulator is preventing or insulation is giving such a protection. Then it is straight away taken to a transformer. So okay, so automatically we know that this line is having a up to 25 kV, 25 kV 50 hertz. So automatically, so inside that it will be step down to a required amount of power, okay, required amount of voltage. Then it will be allowed to fall through a rectifier. This entire arrangement is meant for DC motor, DC locomotive, DC traction. Okay, DC traction. When whereas in case of AC traction also some transformer will be there. After the transformer, immediately through power modulator, it will be given to a series motor, induction motor. But whereas in case of DC, so automatically this AC power has to be converted to DC. Okay, so that is the reason why here rectifier. Before rectifier, we have to step down to a required voltage. Then after that smoothing choke in a high amount of high value of inductors, nothing but high value of inductors connected in order to have a continuous current. In order to have a continuous current. So this is a DC motor. Okay, so this is a DC motor. So that will have a driving the in turns it is connected to the driving wheels. So automatically, so a number of driving wheels can be connected with the DC series motor in between like this. So whatever may be the direction of the rotation and whatever may be the speed of the rotation of the motor depends on that the driving wheel speed also will be there. So this is how this entire railway, that is electric traction, is working. Okay, so whenever this traction is employed in suburban, urban, that is city side, and if you go for any main line, okay, which can go from state to state, cities to city, so more than 10 kilometer it need for every stop, and all it will be considered as a main line. So suburban line usually 2 to 5 kilometers. Okay, so suburban lines, and urban or city lines we can able to say that it is between 1 kilometer. Every frequent stopping is happening 1 kilometer. So automatically, so when we are to go for a different railway lines, so automatically, so entire starting from the overhead conductor, so which is supported by the catenary, okay, catenary level 1 and 2, okay, and complex like that you can able to see that. So we have to have a different infrastructure. So what I mean to say is, so rail track and all may be same, but we have to go for the overhead line, starting from overhead line to engine and all, we need a different infrastructure. So in order to know that, what is the amount of power required if the particular vehicle has to particular engine has to go with a certain amount of speed, so that has to be calculated, so that we can able to understand from the speed time speed time curve of any railway line. Okay, so what is a typical speed time curve for mainline services? This is a curve drawn between speed and time, and taking the speed in kilometer per hour on y-axis and time in second or minutes on x-axis. Okay, so it will be a graph like this, in the x-axis. X-axis we will have a time, and y-axis we will have a speed in kilometer per hour. So automatically what will happen? So initially during the acceleration, time to time it will be going. After that, it will be settled down. It will reach the maximum speed. It will be continuing. Okay. So during the coasting period, what will happen? I will cut down. I will cut down. Automatically, it will drastically decreasing. But if you are continuously allowing coasting, take much long time to stop. So I have to apply the braking. Okay. If you see, the curve, if you see the graph of that, it is somewhat similar to that of trapezoidal, a trapezoidal curve. Okay, so whatever may be, so this curve, actual curve may be different between the main line and suburban and urban lines. Okay, so whatever it may be, so we can able to fix it is suppose if it is like this. Okay, say especially main line will have more long thing, after that it will go. Okay, so it will like this means it is also can be fixed as a fitted as a trapezoidal curve. Okay, so that is how we are going to solve that. If the given a complete information of the motion of the train, that is distance. Okay, if you know the distance to be traveled, so this usually taken as this is the starting point, and this is the point where the next station is there. So between the distance is distance. So this is what distance. Usually the distance is speed into time. Speed into time. So this is the originating station, this is the destination. Okay, next station. So this graph usually drawn between these two stations only. So how much time it has to give acceleration, because if you know or if you fully study this curve, how much time I have to give acceleration, then how long it can go sustain in the particular speed. Okay, usually after overcome the moment of inertia and certain speed is reached, so it can only to overcome the resistance that is offered on the track line only has to be supplied, so it can keep on continuously maintaining. Then after that, if you cut down, okay, this is called coasting period. So this here, there won't be any supply will be provided, so it will be slightly start decelerating because no supply is given, and with the moment of energy, with the kinetic energy stored in the particular one, it will be keep on used because of using of the particular kinetic energy, it will start decelerating. But we cannot allow only that particular depend on costing time only. So after a certain time we have to apply the braking, so automatically we know what is braking. So you know the four quadrant operation of any AC and DC drive. So if forward motoring means in the forward motoring direction itself we can have forward braking. So simply if we are cut down the supply, what will happen? So in case of a DC, here where the DC motor is there, so back EMF will be more than the supplied voltage, so current will be start in the reverse direction, motor will be acting as a generator. So that will make the particular engine to very quickly coming to rest. Okay, that is called braking, that will reach the particular destination. So for these things to know that, we should know four different time curve. Okay, speed time curve. So that is called, first one is acceleration. First one is acceleration. First one is acceleration. Second one is free run or constant speed run. Free run or constant speed run. So that is what here up to this acceleration, and up to from here to here it is called free run and constant. So whatever the period coasting means, we are not giving supply, we are simply allowing the train to run on its kinetic energy stored. Then we are going for the retardation or braking. Okay, so four different, this entire speed time curve can be divided as a four different curve: acceleration, free run, and coasting and retardation. If you see any train, if you travel in any train, this is what happening. Okay, after a certain period, acceleration will go, then it will be keep on going in a constant speed. Then after that, whenever a station is near, it's approaching next, then automatically coasting will be there. So exactly at the station, when it is reaching the platform, so after certain exactly at the signal where the red is there, so it will be stopped, that is braking, retardation. Okay, so here what we can able to see next, this is what a graph for that. Okay, if you see that, this is what, this is a main line, this is a graph, speed time graph for main line. Okay, main line, what will happen? So at initially, okay, this is, okay, this is happening in seconds. Okay, I have taken up to 1300 seconds like that. So initially the train starts. Okay, so up to this is called rheostatic acceleration. That means the moment of inertia, it is overcome. In order to overcome the moment of inertia, it has to produce very high amount of torque. So then only it will be, so more resistive is offered in the track. Okay, rail track. So that is why it's called rheostatic acceleration. After that, it is keep on increasing very quickly, speed curve. Then here it is free running only. So there won't be any resistance. Very low resistance is only is offered for the track. Okay, so it'll only we have to maintain. Then after this point, we can cut down the supply. So because of that, due to the kinetic energy stored, the coasting will be keep on going. Okay, coasting will be keep on going. So the train will be keep on going. After reaching this point, it will be braking. Okay, so one second. So, see if you see that all the four speed type curve are coming here. Okay, acceleration, acceleration is there. Free running or constant speed is there. Then automatically coasting is there. Here retardation or braking also is there. Okay, so this is a graph for the main line. Suppose if you want to see, this is the particular one for the suburban. Okay, so suburban or city. Okay, so automatically if you see that, so we are going to have immediately acceleration. After that, we are not allowing any free running, so it will be just coasting, then braking. Okay, suppose this is for urban. Okay, suppose suburban means so very long time it will go for acceleration, then simply they will cut, it will keep on coming down. Then finally, whenever the station is very nearer to approach, then it is coming down. Okay. So if you see here, that's what here. If a type of service is urban, okay, so acceleration usually how it will happen is kilometer per hour per second. Kilometer per hour per second. So per second it will be 1.5 to 4 kilometer per hour per second. So automatically the retardation also 3 to 4. So retardation has to be happen in the same way. So then only it will be coming down to braking or stopping. So maximum speed of any urban type of service is 60 kilometer per hour. So distance between the station usually 1 kilometers. Here urban is nothing but city. So suburban if you are taking means that is the same thing, but if you see that maximum speed can be little bit higher, and also distance between the station is 1 to 8 kilometers. This is what main line. Usually acceleration is happening very very slowly. Okay, but retardation okay also will be slowly, but speed can be reached very high. Okay, speed can be reached high, and usually the distance will be more than 10 kilometer. Okay, so that is the reason why if you have the experience of traveling between in Chennai, okay, so Egmore to Tambaram, if you see any train, okay, so if any mainline train is started, so maybe next station maybe Mabalam, then they may be reaching Tambaram if it goes to south side. Okay, if you see that our suburban, okay, suburban train exactly if it is both at station, mainline train and as well as suburban train that is coming towards Sengalpattu means if you see there, so before the main line train is coming to Tambaram, that is Mambalam, you can able to see the suburban train will reach that particular Mambalam. So very often this is happening. Those who have missed the train in the Egmore, okay, so 1 or 2 minutes or 3 minutes like that, if they missed the train, they will immediately catch the train, suburban train. Okay, and they will reach Mambalam before the main line train reach Mambalam. Sometimes even Tambaram. Okay, so because the acceleration is more. Okay, okay, and also retardation also very quick. Okay, speed somewhat less, but because of the acceleration, huge acceleration happening because the stop distance between the stop is very less. Okay, so this is a reason. So, but if you main if you see that acceleration per kilometer per hour per second is very, very less, zero point 0.6 to zero point 0.8, but it will keep on going, continues for long time. Okay, long time. Then after reaching a very high speed, okay, after that only they will be running free running periods. There is no any free running period as far as the urban and suburban cases concerned. Okay, so so here the acceleration is nothing but a notching up period. So between the 0 to T1, so 0 to T1 until it reaches the T1, okay, it will be calling as a notching up period. So especially, so rheostating, it will call also called as a rheostating acceleration. So huge amount of power has to be generated. So especially in order to overcome the, it need a very high torque. Okay, in order to overcome to that, at initially dead weight of the train, then after that it need a very high starting high torque for continuous for until this period, until this period T1. Then current will be here, the current will be remain constant, supply voltage will be increasing. How we are going to increase the acceleration in case of electric traction means, to the engine what's the current it is drawing will be same, but adjusting the firing angle of a rectifier arrangement, we have to keep on increase the voltage. Okay, so that is why supply voltage will be increasing, and tractive effort also will be remain constant because of the voltage is increasing. The rotational speed of a motor will be keep on increasing. Okay, current will be constant, tractive effort will be constant because of the supply voltage is increasing. So it will try to accelerate at more speed. Okay, acceleration will be constant. So during the speed curve running and acceleration, speed curve running period T1 to T. So actually T1 to T2, T2 only we are calling it as speed curve running. Speed curve running period we are taking it as a speed curve. Here at this junction, so from this point to this point, so voltage will be constant. Voltage will be constant. Okay, current will be decreasing. Okay, current will be decreasing because now no need of very high current for producing very high torque. So only to maintaining, okay, at the particular speed. Okay, so slowly only it is going to increase. So automatically we can decrease the current. So after increasing the voltage, I am stabilizing the voltage at this point. After stabilizing voltages, I am start decreasing the current. Okay, I am start decreasing the current, and it will reach some own constant value. Okay, so this is what happening during the acceleration, and during the free run period. Okay, free running period. So this is called T2 to T3. T2 to T3 is called as. So this is not based on the time. This is based on the curve. Okay, after reaching, say for example, 100 kilometer per hour particular train speed, okay, maximum speed, it is reached that. Then after that, it is allowed to run on the same speed, free running period. So during this period, train runs with a constant speed and constant power is drawn. So what is the voltage? What is the current? It will be remain same. Okay, so during the coasting period, the power supply is cut off. Actually, if you travel in the any suburban train or urban train, you can very easily we can able to reach after acceleration. Suddenly, we can able to realize. Okay, so coasting period. So cut off means power cut off means it is cut off to the engine. Okay, and the train is allowed to run under its own momentum. That means whatever the kinetic energy is stored, okay, on its own momentum, it will be allowed to run. The speed of the train starts decreasing. Slowly, it starts decreasing on account of resistance to motion of the train. So then the rate of decrease of speed during the coastal period is known as coasting retardation. So this is called coasting retardation. But if you are keep on allowing, okay, if you keep on allowing the particular coasting retardation, it will take much longer time to reach zero. Okay, that means to stand still, come to standstill, or just come to stop. But I have to stop exactly at this distance. So because this is, you see that this is the distance. This distance is nothing but this entire curve. Okay, how much speed and how much time it is taken. So I cannot allow until that. So definitely I have to start doing the braking operation. Okay, that is what here is braking or retardation. At the end of the coasting period, the brakes are applied to bring the train to rest. During the period, speed decreases rapidly and finally reduces to zero. So whenever we are applying these things, automatically what will happen? So we are applying, we are using the concept of regenerative braking. Regenerative braking. That means my motor, okay, which as per us here, I am using a series motor. This is a DC tracking. This motor will be allowed to run. Okay, suppose in case of AC, okay, see induction motor will be there. Whatever the motor will be allowed to run as a generator, then automatically it will fed back the energy, okay, to source, so that that we can able to return it back to the conductor where we are tapped by adjusting the power modulator firing angle in such a way that it will be acting as a inverter. Then automatically very rapidly it will come to reduce this zero. It will stand still because now energy is taken away. Now energy is taken away, so I am not allowing to utilize by the train. I am just taking the particular kinetic energy from the system, so automatically that will make the particular train to stop very quickly and come to standstill. Okay, so this is what I told earlier. Okay, so in case of urban, suburban, like that, it will be like this. Okay, so if you see what are all the terminologies that is used in the particular, here is called crest speed. One terminology is called crest speed. That means the maximum speed attained by the vehicle during the run is known as crest speed. As far as this case is concerned, 100 kilometer per hour. So speed is kilometer per hour. As far as the main line characteristics I have taken here is, okay, for this one, crest speed is 100 kilometer per hour, and average speed is nothing but distance between the stops and actual time of run. What is the average speed is distance between the stops. Suppose if you know how much distance it is traveled from, if it is a reference exactly at 1200 seconds it is stopped. Okay, so what is the distance? How much is the distance traveled? How much is the distance traveled? And divided by the actual time of run. Actual time of run is nothing but 1200 seconds. So if it is that, I can able to calculate the average speed. Average speed. This distance between the stars is fixed. It's fixed. At any point of time, it will not vary. At any point of time, because it only thing varying is if I'm increasing the average speed, automatically actual time of run will be decreasing. If actual time of the run is increasing, average speed will be decreasing. So these two only will be varying one. Okay. So whereas the distance between the stop is remain constant. Okay, remain constant. Okay. And another one is a very important terminology that we have to understand from the speed. Okay, speed time curve is schedule speed. Schedule speed, very often you may heard about this terminology in railways. Schedule speed. Schedule speed is nothing but distance between the stop and actual time of running plus stop time. Stop time, this is what schedule. So this train is scheduled speed is like that, they'll mention. So you may is the meaning of scheduled speed is nothing but addition to the actual time of running, they are taken the stop time also. Some stations, major stations, district headquarters, like that. Okay, so if any important city or if any very important place means, they usually take. Suppose if it is a junction means, it will take some 5 to 10 minutes. Okay, so for signal and all, usually more passengers will be they will leave or they will enter. So like that, if it is that means usually 5 to 10 minutes. So other station usually 1 to 2 minutes, 3 minutes. If it is suburban means irrespective of the particular place, 1 or 2 minutes. So all the stop time also, if it is considered, stop time also if you consider means, for calculating the average speed means, that is called scheduled speed. That is called scheduled speed. So compared to the average speed, what will happen? So scheduled speed will be very less only, because here taken actual time of run only. Here in addition to that actual time, stop time also is there, that is in the denominator, so automatically that will decrease the schedule speed. Okay, so that is what schedule speed is always less than the average speed. Schedule speed is always less than the average speed. So if you see, if you want to, I want to fix it, in any standard practice shape means I can able to fix it in a trapezoidal. Okay, if you see that, and likewise here also I can able to fix it in a trapezoidal. Likewise here also I can able to fix it as a trapezoidal. If you see that whatever may be the actual speed time curve of urban suburban mainline, whatever it may be, I can able to because I have to analyze. If I have to analyze or if I have to do how much time, how much speed calculation, and all, I am able to fit it in a fixed shape only. So here it is not a fixed shape. So if I am fitted in a fixed shape means, so it will be like a standard trapezoidal or trapezoidal like this. So automatically you know how to calculate the area. Suppose if I'm having a trapezoidal like this, so here as per the suburban is concerned, if it is like that, automatically what will happen? So by knowing that what is the distance between this time and this time and what is the height difference, keeping the particular one and 90 degree. So here 90 degree, here 90 degree. I am making this one as H1 and this one as H2 and this one as a D. So area of this particular trapezoidal is what is that? Half into D into H1 plus H2 meter square. So both D, H1, H2 all has to be taken in meters means meter square. So if it is automatically I can able to calculate the area. Okay, what so standard means I can able to divide them as a triangular. This is two triangular, okay, and one rectangular shape I can able to get. Suppose if you see that here I am getting a one triangular and another one triangle. This is one rectangle. This is for a standard trapezoidal. But if it is a suburban and other thing means automatically it will not give a standard trapezoidal. So in order to know that if what is the distance between this to this graph, this to this, okay, I have to measure this distance and exactly 90 degree from here. What is the distance? Exactly 90 degree from here. What is the distance? So if it is H1, H2 and D, I can able to measure the area of the particular trapezoidal using this formula. So once the area is known that, so that is nothing but we can able to say how much the distance we can able to travel and all for all analysis I can take it that. Okay. So here we have seen that already. So I am just fitted. This is for the main line. I am just fitted the main line speed in the trapezoidal curve. This is a standard trapezoidal, fixed standard trapezoidal curve. I am having if I'm assuming this as a acceleration and free run, adding the coasting and the retardation, I'm just making here what is happening. I'm just making the rheostatic acceleration and acceleration. So I'm taking completely as acceleration and completely this as a retardation or braking and completely this as a braking. I'm just fitted the particular one in a trapezoidal. So I may have three different area. One is a one triangular, another is a triangular. In between that, there will be a rectangular shape will be coming. So I'm just taking three time. So until it is reaching free run, it is T1. So total period of free run, this is T2. Total period of retardation, okay, retardation or coasting. In addition to the coasting, it is T3. Okay, so I am taking like this. So I am taking alpha is the acceleration in kilometer per hour per second, beta is the retardation in kilometer per hour per second, and Bm is the crest speed in kilometer per hour. That is the maximum speed usually happening in here. Okay, here only it is happening. Okay, so T is the total time for run in seconds. So automatically, if I'm taking these all these things, so how much time it is taken for acceleration? Tm is nothing but Vm by alpha. Vm by alpha. And how much time it is taken for retardation in second? That is T3 is nothing but Vm by beta. Okay. So time for free run. Okay, is nothing but we can very easily calculate by knowing that T2 is nothing but total time minus T1 plus T3. So that is T1 is nothing but Vm by alpha, T3 is nothing but Vm by beta. So if a total distance of run in kilometer, distance traveled during acceleration, distance traveled during very run, distance traveled during retardation. So I am taking three S's, S1, S2, S3. So adding this only will be my total distance travel. Okay, so if I am taking S1, okay, distance traveled during acceleration. This is a triangular. So you know how to calculate the area of this. So you know how to calculate the area of this one. So half into VMT1. VMT1 divided by 3600. Okay, this is nothing but in terms of seconds. So 3600 seconds, 60 into 60. So 60 minutes, each minute is having 60 seconds. So totally 3600 seconds. Likewise, here for S3 also is a triangle. So I am taking half of that only. So VM T3 divided by 3600. Whereas S2 area is a rectangular shape. I am taking VM into T2 divided by 3600. I know what is T1. I am simply substituting VM by alpha. So that is nothing but S1 is Vm square divided by 7200 alpha. Likewise, S3 is Vm square 7200 beta. But whereas S2 is Vmt by 3600 minus Vm square 3600 alpha, Vm square 3600 beta. Okay, so because we already know that T2 is equal to T minus T plus T3. So I am simply substituting, okay, T. What is the T value? I am simply substituting. Now I have to add all these things. S1 plus S2 plus S3. Okay, S1 is this S2 term, then S3 term. So if I'm taking, okay, I can able to take out of this Vm square alpha, I can take a common one. I'll have 1000 to 1 by 7200 and minus 1 by 3600. For this beta term, which are all having a beta term also, I can take a common outside. Vm square by beta, they're also same. 1000, 1 divided by 7200. Okay, I can, and 1 minus 1 by 3600. And another one term is there. Here it is nothing but it is same coming there as a same. Okay, so if I am simplifying these things, okay, I'll get Vm square by alpha. So I have to take a, LCM. Okay, so then 7200. I am taking 1 by 1 minus 2 by 7200. Vm square 1 minus 2. So here, if you take that, automatically what will happen? It will convert to minus sign. So this will be having plus sign. Okay, and BMT, that is nothing but what is the crust speed multiplied by the total time divided by 3000 minus what is the crust speed maximum speed square divided by 7200 into acceleration in kilometer per hour per second minus what is a Vm square crust speed square divided by 7200 into retardation, that is deceleration. So at what kilometer per hour per second? If I know that, I can able to know what is S. I can able to know what is S. That is nothing but total distance of run in kilometer. Okay, so this is how it is happening. So if you know these things, I can able to get, okay, I can able to substitute like this. Okay, so I can able to make it. If I am taking the particular distance also here, it will be equal to 0. Then I can able to take Vm square outside. Okay, so and I'm taking as a common. Okay, 3600 years will be coming. So it will all taken. Okay, so it will multiply by S is multiplied 3600. So my equation will be converted as Vm square multiplied by 1 by 2 alpha plus 1 by 2 beta minus Vmt plus 3600 years. So taking the k, because this is going to be constant. So automatically, if you take what is the acceleration or what is the retardation kilometer per hour per second. If you take that as a k, I can able to make it this as a constant. So Vm square k minus Vmt plus. So it is an equation. It is a quadratic equation. I can able to convert it as a quadratic equation. So here I have taken A is equal to K, B is equal to minus T, C is equal to 3 services. So you know that what is the formula? Minus B plus or minus square root of B square minus 4AC by 2A. So I am substituting A. What is A? B is minus T. Minus T means here minus B plus T. So if I am substituting, I am getting what is the maximum speed. Okay, what is the maximum speed it can reach? That is very, very important. So with the known acceleration speed, that is what is a kilometer per hour per second, and retardation, that is decelerating, what is a kilometer per hour per second. If these two are constant, by knowing this equation, I can able to tell what is a maximum speed. Okay, so for a positive sign will be much higher than the possible practical value. So Vm is equal to total traveling time divided by 2k. Okay, so here what is k? K is equal to 1 by 2 alpha plus 1 by 2 beta. That value is a constant. So square root of t square divided by 4k square minus 3600. Here s is total distance to be traveled. Total distance to be traveled. Here total time of travel, total distance to be traveled divided by k. If you know that, I can able to get Vm. Okay, I can able to get Vm. This is the knowledge very much important. This is a knowledge very much important. So this, whenever we go for electric traction, whenever we go for electric traction, so I can able to calculate the distance. Okay, if I'm going with the alpha and beta this much value. If I'm going with the alpha and beta with a certain amount of speed, I can able to. So in ulta direction, if I know the value of alpha, beta, and s, there is nothing but distance we travel, I can able to calculate what is the maximum speed that can be go or that can be traveled by the particular engine. Automatically all the connected compartments and etc. Okay, so this is the very important concept. Okay, typical speed time curve of any three services. I have derived it for here only for the mainline services. So it is, you have to study the urban and suburban line services also. What will be the corresponding equation? Is there any clarification? Is there any clarification? No clarification, huh?
No, sir, no.
So I wish to ask some questions. Okay, I will ask. Balachandar, Balachandar, are you able to listen? Say yes or no. Balachandar, Balachandar. Am I audible, first of all?
Yes, sir.
Yes, sir.
Yes, yeah, Balachandar. Then what about Balachandar? He's not online, huh?
Sir, I was in online, sir.
Okay, tell me, Balachandar, what are all the power modulators, power converters for electric traction? You know some fundamental, no? What you know, what is electric traction? You know what is power modulator? It is, you know what is the need of power modulator? You know what is drive concept and all. You tell me what are all the power modulators may be suitable for AC traction? For AC traction.
Sir, power modulator means the flow
Power
of
converters.
energy.
Power converters.
Sir, power
Converters. Power converters.
converters.
Which converter is suitable for AC traction? Okay. Amalapesto. Amalapesto.
Yes, sir.
You tell me which power modulator may be suitable for AC traction. Okay. Prem, unmute
Sir,
your mic. You tell me, Prem, what are all the different current collectors can be used in electric traction? Current collectors. What is current collector in electric traction? Where it is used? We are all finally here. Okay. After seeing your mark sheets, and the interviewer, those who are going to recruit you, maybe interest. Okay, they may show some keen interest in knowing whether you know these things, basic things. Okay, so they will not ask anything in depth in this particular subject. They may be asking, "Oh, you studied electric vehicle, electric traction also." Okay, so what is current collector? What are the different types of current collector? Power modulators. It is their curiosity, no? Their definitely with the curiosity will be there. So employer, those who are going to recruit, even though you may be studied naval architecture, mechanical, or food processing, or what are in the petroleum mining, irrespective of that, if you show that, if your mark sheet, because in mark sheet they know very well about the background, department background. So by knowing your qualification, okay, BE or B.Tech in the particular naval architecture, mining, and all. So they may be very much first they will look into your project work. So very often this is happening, and this will only going to happen you also. So they will look into your project work. Okay. So next to the project work, they will see the elective subject you have chosen. Okay, you have chosen during your study. Okay, so because the elective subject and all, so especially the open elective subject and all, with some curiosity of knowing these things only, you will be selected because the core subject and all, it will compulsory. Whether you like it or not, you have to undergo that course and you have to get some knowledge and pass also. Minimum requirement is to pass. But open elective and elective subject and all, with some curiosity or with some interest in knowing those things only, you may be chosen that. Is their idea. Okay, I don't know how it is happened. Okay, so their idea is you have chosen the particular subject with that interest only. So they, in turn, they want to know what you learn or what you know about that. So definitely in interviews, so open elective project, mainly they will concentrate on project. Suppose why you are, if you want to justify why you have selected the particular project work means, if you say that because of the interest in the, because of the knowledge I gain in some electric courses, so that motivate me to do some project work or that motivate me to do some problem solving on this only, that will be well and good. So that is the way they are expecting. Okay, that's the way we are expecting. What are all the acquiring skills, acquiring knowledge, then acquiring skills, how you are implemented the mixed blend of these things, mixed blend of the knowledge you gain and as well as skill you gain from your core course to solve a practical problem, day-to-day problem, industry problem, or which is a very more important, and no one else find any solutions, or the solution found out is not suitable. Still, a lot of development has to be given. So that small a miniature model, if you are able to make and if you are able to suggest solution, that only will be attractive. Okay, so especially engineering students and all, it is not a mere arts and science courses like that. Okay, irrespective of that, certain rules will be there, certain tables will be there, certain procedures will be there. So whether you like, so you are not going to do anything after studying arts and science. So nothing going to be contributed innovatively. Okay, only thing is you have to maintain. What is the existing procedure of maintaining files, ledgers, financial statement, and this statement, that statement, office procedure? We are going to maintain in that only. But as far as engineers' role is concerned, we are not here for maintaining anything. We are here for mainly to give a solution to the latest one. Okay, so solution to the problem. How innovatively, how cost effectively, how quickly we are giving the innovative solutions only. So that type of sharp, okay, so sharp knowledge, okay, that we can able to gain, and that only the employer, those who are going to employ you in their company or in their concern or in their organization, they wish to see that how sharp you are, how that for that, to test that, to assess you, that they will select these type of subjects only, because these type of subject now everyone knows, even children, even a small, so their kids are there, they are a very much curiosity knowing what is electric car, how it is running, how long it will go, what is electric train, okay, how it is working, etc. Even in the school days, school books and all, now we are able to see that. Okay, so in their curriculum itself. So they are very much curious. They are also, so likewise in engineering. After knowing that you have undergone this course, so definitely next to the project work, next to the major project work, they will be looking to your mark sheet, credentials, or whatever may be the mark sheet you are showing. They will be very much looking to that elective chosen, because elective nobody can force. As per the thing, nobody can force you to undergo. You have to select with the choices, number of choices you have to select. So they may be, they want to know about that, especially after seeing the subject. So they may be asking you so many questions. What are the latest car, electric car, how much kilometer it go, what is a uh, as an engineer, because engineer means they should know more. Okay, so what is a power type, power modulator type? What is a battery type they are using? What is a capacity, energy capacity, current capacity, specific density? Lot of things they will be asking. Okay, curious to know these things. Okay, so you should have a develop. Okay, that type of thing. Okay, by referring materials and other things. Okay, even in classroom also, you should not be very much silent. Okay, so whenever I'm asking any doubts, so far, maybe around we have completed some 35, 36 periods. Very few only they are opening their mouth. They are asking some few doubts. Very few, less than five, less than three only people only. They are asking some doubts. Remaining and all, that should not be. I'm not. I'm just encouraging you to ask more questions. Okay, so that type of thing, that type of habit you should develop. Okay, so tomorrow we will solve one problem. Then okay, so because this subject, that is only one problem only. So that is also in a speed time curve. Then after that we move to different power electronic systems, that is in hybrid electrical vehicle. With that we will complete the fourth unit. Okay. If you have any doubts, okay, so I will allot. I usually am asking, because you people, if you are asking more doubts only, okay, that I can able to tell you the correct answers. Okay, if you are not listening, if you are not interesting, if you are telling some answers only, yes, whether you understood or misunderstood, at least some, okay, so somewhat they understood, like that I can able to assess. If I keep silence, I cannot assess anything. Okay, so and moreover, it should be it's online class. It should be more interactive. Okay, so I'm expecting at least some changes, at least in the final CO, final course outcome or final unit. Okay.